In the vast, dark silence that lies between the stars, a lone emissary from Earth continues its timeless journey, NASA's Voyager 1 spacecraft, a symbol of human curiosity and ambition. Launched in 1977, Voyager 1 was part of an extraordinary mission that would go on to define an era in space exploration. Together with its twin, Voyager 2, it was built to explore the outer planets. But what it ultimately achieved surpassed every expectation. The Voyager missions marked a watershed moment in the history of space science. Designed initially to conduct close-up studies of Jupiter and Saturn, these pioneering probes delivered breathtaking images and unprecedented data, transforming our understanding of the gas giants and their moons. Yet, even as Voyager 1 completed its original mission, it kept going, pushed onward by the relentless drive of discovery embedded in its very design. Voyager 1's journey did not end at the edge of the solar system. Instead, it became the first man-made object to enter interstellar space, crossing the heliopause, the boundary where the solar wind gives way to the interstellar medium, on August 25, 2012. With this historic achievement, Voyager 1 stepped beyond the protective bubble of our Sun's influence into a new and uncharted realm. It was a leap not just across space, but across the boundaries of human knowledge. As it travels more than 14 billion miles from Earth, Voyager 1 continues to send back signals, whispering secrets from a region of space no other human-made craft has ever visited. It relays vital information about cosmic rays, magnetic fields, and the density of interstellar plasma. Clues that help scientists piece together the nature of the space between stars. But Voyager's legacy is more than just data. It is also deeply philosophical and symbolic. Affixed to the spacecraft is the Golden Record, a phonograph containing sounds and images selected to portray the diversity of life and culture on Earth. It includes greetings in 55 languages, music from across the world, and even the brainwaves of a young woman in love. This record is a message to the cosmos, a hopeful gesture that speaks to our species' longing to connect with whatever might lie beyond. In every sense, Voyager 1 is more than a spacecraft. It is a time capsule, a sentinel, and a storyteller. It has witnessed the auroras of Jupiter, the rings of Saturn, and now the strange silence of the interstellar deep. Its journey reminds us that exploration is not just about where we go, but what we learn about ourselves along the way. Even now, over 4 decades since its launch, Voyager 1 continues its odyssey, a tiny speck in a vast ocean, sailing ever farther into the unknown. It carries with it the dreams, questions, and hopes of a planet bound by gravity, but driven by imagination. As long as Voyager 1 speaks, even in the faintest signals, humanity is still out there, listening, learning, and reaching for the stars. Voyager 1, the unstoppable explorer, and a recent cosmic silence. Voyager 1's epic odyssey through our solar system and beyond is nothing short of legendary. Over the decades, this pioneering spacecraft has peeled back the veils of cosmic mystery, unveiling long-hidden secrets that have deepened our understanding of the universe. From the swirling storms of Jupiter to the icy rings of Saturn, Voyager 1 has offered us front-row seats to the most majestic sights in our solar neighborhood. But its greatest achievement lay ahead. When it crossed into interstellar space, Voyager 1 shattered the final frontier, becoming our first messenger to venture beyond the protective bubble of the Sun's influence. And even now, more than 45 years after its launch, Voyager 1 continues to surprise us. Scientists across the globe are still interpreting the groundbreaking data it transmits, confirming new findings that have the potential to revolutionize astrophysics and reshape how we understand the cosmic environment that surrounds our solar system. Every byte of information sent back from this tiny spacecraft, now over 14 billion miles away, is a treasure trove for science. The legacy of the Voyager missions is monumental. They stand not just as triumphs of engineering and science, but as symbols of humanity's insatiable curiosity and unwavering desire to push boundaries. They are beacons of inspiration, reminding us that even the smallest emissaries can carry the weight of our greatest dreams. However, Voyager 1's journey has not been without challenges. Recently, the mission encountered a puzzling interruption. After decades of steady communication, the spacecraft began sending back distorted data to Earth, signals that confused even seasoned mission engineers. It appeared that Voyager 1's telemetry system, which reports on the status and health of the spacecraft, was malfunctioning. For a time, it was as if our voice in the stars had gone faint, as if a long-trusted friend had grown distant and unrecognizable. But in true Voyager spirit, the story didn't end there. The incredible team at NASA's Jet Propulsion Laboratory sprang into action, navigating decades-old software, ancient hardware, and limited resources to diagnose the issue. In a feat of modern-day engineering wizardry, they managed to recover, contact, and restore normal communication, once again proving that even across unimaginable distances, human ingenuity can bridge the void. So join us in today's video as we dive deep into the story of Voyager 1, its triumphs, its mysteries, and the remarkable resilience of both machine and mankind. From its humble beginnings on Earth to the farthest edge of the solar system, this is more than a mission. It's a journey into the very soul of what it means to be human. The stars still call, and Voyager 1 is still answering. Voyager's original mission, a leap into the unknown. When the Voyager mission was conceived in the early 1970s, it was nothing short of audacious, a daring leap into the unknown. The primary objective was ambitious: to collect detailed data on the 4 giant outer planets of our solar system: Jupiter, Saturn, Uranus, and Neptune, through close-up exploration that had never before been attempted. At that time, these planets remained largely mysterious, distant orbs observed only through Earth-bound telescopes. Their complex systems of moons, magnetic fields, atmospheres, and potential ring structures were shrouded in uncertainty. Voyager was designed to change that forever. The mission sought to pull back the cosmic curtain, sending back high-resolution images and scientific measurements that would unravel the secrets of these colossal worlds. From the swirling storms of Jupiter to the elegant rings of Saturn, from the icy blue expanse of Uranus to the deep azure hues of Neptune, the Voyager spacecraft promised to deliver a view of the outer solar system unlike anything humanity had ever seen. But despite the excitement, skepticism loomed large. Many questioned whether the spacecraft could even survive the launch, let alone withstand the immense distances and harsh conditions of deep space. These concerns were far from unfounded. After all, no mission had ever attempted such an extensive voyage through the outer solar system. The journey would take years. The technology was untested on such a scale, and there were no guarantees of success. Fuel limitations, signal delays, mechanical failures. Any number of problems could have ended the mission prematurely. And yet, the team pressed on. Against the odds, Voyager 1 and its twin, Voyager 2, not only survived, they thrived. They conducted flawless flybys of the target planets, capturing images that astonished the world and collecting data that transformed planetary science. Thanks to Voyager, we discovered active volcanoes on Jupiter's moon Io, observed complex weather systems on Neptune, mapped intricate magnetic fields, and even detected unexpected ring systems around planets like Uranus. What was once theory became fact. What was once invisible became breathtakingly real. In hindsight, what seemed like a gamble turned into one of the greatest scientific triumphs in human history. And remarkably, the mission didn't end with the outer planets. Voyager's story was just beginning. Propelled by its own momentum, Voyager 1 journeyed on, setting its course for the stars. Today, it continues its odyssey in interstellar space, carrying with it a golden record, a message from Earth, a time capsule for any distant intelligence that might one day discover it. Voyager's triumph, a legacy of ingenuity and discovery. However, against all expectations and despite immense technical hurdles, the Voyager spacecraft defied all odds, embarking on an extraordinary odyssey of scientific exploration, an odyssey that continues to shape our understanding of the cosmos even to this day. Launched in 1977, Voyager 1 and Voyager 2 were more than just spacecraft. They were symbols of human ingenuity, resilience, and an insatiable thirst for discovery. At a time when direct data on the outer planets was scarce and only a handful of missions had ventured beyond Mars, Voyager dared to do the impossible. It pushed the boundaries of our planetary knowledge, becoming the first mission to provide close-up images and in-depth data on Jupiter, Saturn, Uranus, and Neptune, forever transforming how we understand the gas and ice giants that inhabit the outer reaches of our solar system. Engineers and scientists faced enormous challenges. With no precedent for such a long and complex journey, obtaining precise measurements of distant planets, their atmospheres, rings, and moons was a formidable task. The vacuum of space, intense radiation belts, signal delays across billions of kilometers, these were just a few of the formidable obstacles the mission had to overcome. And yet, Voyager was ready. Both spacecraft were equipped with a suite of 11 advanced scientific instruments, each meticulously designed to capture different aspects of the planets and their environments. These included imaging systems for capturing detailed photographs of planets, moons, and ring systems, infrared and ultraviolet spectrometers to analyze atmospheric composition and thermal radiation, magnetometers to measure magnetic fields, cosmic ray and plasma detectors to study solar wind and interstellar particles, photopolarimeters and radio science instruments to probe planetary densities and structures. With these tools, Voyager did far more than anyone expected. It discovered volcanoes erupting on Io, detected complex ring structures around all 4 outer planets, revealed the dynamic, storm-filled atmospheres of gas giants. The data returned by Voyager laid the groundwork for every outer solar system mission that followed, from Galileo and Cassini to Juno and beyond. More importantly, it ignited the public imagination, demonstrating that we are capable of reaching out across the vast emptiness of space, not just to see, but to understand. Voyager didn't just travel far. It changed everything we thought we knew about the outer solar system. Engineering the impossible, how Voyager defied the darkness of deep space. At the heart of the Voyager missions lies a symphony of sophisticated engineering and scientific ambition. Each probe, Voyager 1 and Voyager 2, was equipped with a suite of highly specialized instruments designed to explore the farthest frontiers of our solar system. These included photometers, magnetometers, cameras, charged particle detectors, radio antennas, and plasma detectors, each playing a crucial role in analyzing planetary environments, magnetic fields, radiation belts, and distant atmospheric phenomena. Yet, deploying this technology posed a monumental challenge. Operating sensitive instruments billions of kilometers away from the Sun in the cold, silent void of deep space was an unprecedented task. Unlike missions closer to Earth, Voyager could not rely on solar panels for energy, as the Sun's light was too faint to be of any practical use. To overcome this hurdle, NASA engineers turned to nuclear energy, harnessing the power of radioisotope thermoelectric generators, RTGs, a brilliant solution that would become the backbone of Voyager's longevity. Each spacecraft carried plutonium-238, a radioactive material whose natural decay produces heat. The RTGs ingeniously converted this heat into electricity, ensuring a steady, reliable power source that would function regardless of the spacecraft's distance from the Sun or the passing of decades. These compact power plants enabled Voyager's systems to remain operational even as they traverse the frozen frontiers of space, where temperatures plummet to hundreds of degrees below zero and sunlight is a distant memory. Each Voyager spacecraft carried approximately 722 kilograms of payload, comprising scientific instruments, communication systems, and power sources, all meticulously arranged to withstand the harsh rigors of space travel. The probes had to operate with extreme autonomy, capable of managing critical functions and making real-time decisions based on pre-programmed algorithms due to the immense communication delay with Earth. Thanks to this visionary engineering, the Voyager twins have transmitted invaluable data for over 4 decades. They have rewritten textbooks, uncovered new planetary phenomena, and extended the reach of human understanding into the interstellar medium, a realm no spacecraft had ever entered before. The story of Voyager is not only a triumph of science, but also a resounding testament to human creativity, problem-solving, and our determination to seek knowledge, no matter how distant the destination may be. Strategic precision. How NASA engineered the grand tour of the outer planets. Sending a spacecraft into the vast and unforgiving expanse of our solar system is no small feat, especially in the 1970s, when spaceflight technology was still in its relative infancy. The Voyager missions required not only remarkable engineering and endurance, but also strategic genius to ensure their success. One of the key challenges was power management. For the spacecraft to function efficiently and avoid aimless drifting through space, they required substantial and uninterrupted power. A task that NASA solved with the use of radioisotope thermoelectric generators. But generating power was only part of the equation. Planning the journey itself demanded equal brilliance. NASA's engineers meticulously charted the mission trajectories, utilizing an ingenious technique known as gravity assist, a maneuver in which a spacecraft uses the gravity of a planet to gain speed and alter its course. By harnessing the gravitational pull of Jupiter and Saturn, the Voyagers could be slingshotted farther into the solar system without expending extra fuel, allowing them to travel vast distances with remarkable efficiency. The timing of the mission was critical. In the late 1970s, the outer planets Jupiter, Saturn, Uranus, and Neptune were entering a rare, favorable alignment that occurs only once every 176 years. This unique positioning allowed for what NASA called the Grand Tour, a chance to visit all 4 giant planets in a single mission, using consecutive gravity assists to propel the spacecraft from one planet to the next. Initially, NASA envisioned a single ambitious spacecraft to complete this entire tour. However, due to budgetary constraints and technical risks, the agency opted for a more cost-effective and flexible solution, launching 2 identical spacecraft, each with its own specific trajectory and mission goals. Thus, Voyager 1 and Voyager 2 were born. Voyager 1 was designated to fly by Jupiter and Saturn, getting close enough to study their atmospheres, moons, and rings in unprecedented detail. Voyager 2, meanwhile, was tasked with exploring all 4 outer planets: Jupiter, Saturn, Uranus, and Neptune, becoming the only spacecraft in history to have visited all of them. Despite the limitations of 1970s technology, no GPS, no onboard AI, and minimal computer memory, NASA's planning left no stone unturned. Every trajectory calculation, communication schedule, and instrument command had to be programmed in advance with precision and foresight. There was no room for error in the dark and distant void. Against all odds, the Voyager mission persevered. What started as a bold idea evolved into one of the most iconic and enduring achievements in the history of space exploration. These spacecraft not only survived the journey, but also exceeded every expectation, becoming the longest operating and farthest traveling spacecraft humanity has ever launched. Voyager 1's encounter with Jupiter, a turning point in planetary science. When NASA launched the Voyager spacecraft, it did so with high hopes and bold ambitions, but much of what the mission might reveal remained rooted in optimistic speculation. At the time, the outer planets were enigmatic giants, their moons little more than distant, blurry dots captured in telescopic glimpses from Earth. Yet the Voyager mission pressed forward, determined to overcome the uncertainties and break through the boundaries of human understanding. In 1979, Voyager 1 reached Jupiter, the largest planet in our solar system. What unfolded during this flyby marked a historic turning point in planetary science. Among the many stunning revelations, one in particular captured the imagination of scientists around the globe. Jupiter's moon, Io, long thought to be just another rocky satellite, was found to be geologically active. This was a revolutionary discovery. Up to that point, Earth had been considered the only body in the solar system with active geology, volcanoes, tectonic movements, and internal heat flow. Io, smaller than Earth's moon and just a third the size of Earth, defied all expectations. Voyager 1 captured astonishing images of Io's surface, erupting volcanoes, shifting terrain, and widespread lava flows, revealing that this tiny moon was the most geologically active object in the entire solar system. Even more remarkable was the intensity of Io's activity. Despite its modest size, Io was generating twice as much internal heat as Earth. This immense energy output wasn't due to radioactive decay or solar heating, but rather the result of tidal heating, a process driven by the gravitational tug-of-war between Jupiter and its neighboring moons, Europa and Ganymede. As Io orbited the gas giant, it experienced constant flexing, causing its interior to heat up dramatically and fuel continuous volcanic eruptions. The surface of Io, unlike anything seen before, was a vibrant mosaic of sulfurous plains, towering plumes, and lava lakes, with colors ranging from yellow and orange to red and black. Some volcanic plumes were found to erupt hundreds of kilometers into space, a spectacle that redefined scientists' understanding of how dynamic a moon's surface could be. This discovery alone would have been enough to cement the success of the Voyager program, but it was only the beginning. Voyager 1's findings at Jupiter, and particularly at Io, reshaped planetary science. It proved that geologic activity was not limited to Earth, opening the door to new theories about potential habitability on other moons, such as Europa, and later Enceladus and Titan. Voyager 1's flyby of Jupiter was more than a mission milestone. It was a moment that changed the way we look at the solar system. It reminded us that even the most unassuming celestial bodies could hold astonishing surprises, and it underscored the value of exploration, venturing into the unknown, driven by curiosity, only to discover realities far more wondrous than imagined. Voyager 1's discoveries at Jupiter, redefining planetary science. The Voyager 1 mission's close encounter with Jupiter didn't just provide breathtaking visuals of the largest planet in our solar system. It shattered long-held assumptions and revolutionized our understanding of gas giants and their complex systems. Among its most surprising revelations was the geologic dynamism of Io. But that was just the beginning. As Voyager 1 continued its flyby, it unveiled a tapestry of scientific findings that would forever change how we study the cosmos. One of the most unexpected discoveries was the enormity and strength of Jupiter's magnetosphere, the magnetic field that surrounds the planet. Previously, scientists had underestimated its scale, but Voyager 1 revealed that Jupiter's magnetosphere is the largest structure in the solar system, stretching outward until it nearly reached the orbit of Saturn, a distance of over 10 million kilometers. This discovery emphasized just how powerful Jupiter's magnetic influence is, affecting not only its own moons and rings, but also the solar wind far beyond what anyone had predicted. The probe's suite of instruments also penetrated the secrets of Jupiter's atmosphere. It analyzed the planet's composition in unprecedented detail, detecting a mix of hydrogen and helium, the primary elements as expected, but also traces of water vapor, methane, ammonia, and even rocky materials. These findings provided scientists with valuable clues about Jupiter's internal structure, formation history, and the dynamic processes taking place in its turbulent clouds. Through high-resolution imaging and data collection, Voyager 1 captured images of Jupiter's Great Red Spot, a massive storm that had already raged for centuries, and unveiled swirling cloud bands, chaotic atmospheric motions, and fast-moving jet streams. The planet's ever-changing weather systems, driven by internal heat and rapid rotation, painted a vivid picture of a world alive with activity, despite having no solid surface. Even more astonishing was what Voyager uncovered about Jupiter's moons. Not only Io, but Europa, Ganymede, and Callisto. Each of these Galilean satellites showed unique characteristics, from cracked icy surfaces to evidence of internal oceans, hinting at the possibility of subsurface water and even conditions suitable for life in the most unexpected places. These findings collectively expanded the scientific paradigm. Before Voyager 1, moons were often thought of as cold, inactive bodies, mere rocks orbiting planets. But now, They were seen as diverse and complex worlds, some with active volcanoes, hidden oceans, or mysterious terrain, each deserving of further exploration. Voyager 1's mission to Jupiter served as a powerful reminder. The solar system is far more intricate and alive than previously imagined. What started as a mission to collect data transformed into a voyage of revelation, deepening our understanding of planetary geology, atmospheric dynamics, and magnetic fields on a grand scale. This historic flyby didn't just enrich our scientific libraries, it sparked new questions and laid the foundation for future missions. It also inspired a generation of astronomers, engineers, and explorers to continue humanity's relentless pursuit of knowledge beyond Earth. Voyager's unprecedented discoveries. From Jupiter to Saturn. As Voyager 1 departed the realm of Jupiter, it left behind a treasure trove of discoveries that redefined planetary science. Yet, its journey was far from over. With unwavering precision, the spacecraft set its course for Saturn, the sixth planet from the Sun, and another celestial giant cloaked in mystery. But before we plunge into the wonders of Saturn, it's important to reflect on one final, critical chapter from Voyager's exploration of Jupiter: the unexpected discoveries surrounding its rings and moons. In a stunning revelation, Voyager 1 captured the first up-close image of a narrow, dark ring encircling Jupiter. A phenomenon that had eluded astronomers for decades. The ring's existence, previously undetected from Earth, was believed to be composed of fine dust particles, and possibly the remnants of an ancient moon pulverized by past collisions. This finding challenged assumptions that only Saturn possessed rings and opened a new frontier of inquiry into the dynamics of planetary ring systems. Additionally, Ganymede, Jupiter's largest moon and the largest in the entire solar system, came under intense scrutiny. Voyager 1's sophisticated instruments detected the presence of a tenuous atmosphere, an exosphere composed mostly of oxygen. This was a groundbreaking discovery. Up until then, Ganymede was considered geologically dead and atmosphereless. The existence of this thin atmosphere suggested internal activity and set the stage for later missions, such as the upcoming ESA's Jupiter Icy Moons Explorer, USH, and NASA's Europa Clipper. Together, these findings reshaped our understanding of Jupiter as not just a giant gaseous planet, but a complex system teeming with dynamic moons, active geology, hidden atmospheres, and mysterious rings. It was a microcosm of cosmic diversity, waiting to be studied for generations. Voyager 1, at Saturn, unveiling the secrets of the ringed giant. With its instruments still functioning optimally, Voyager 1 journeyed farther into the outer solar system, setting its sights on Saturn. Arriving in 1980, it encountered a world unlike any seen before, an ethereal planet adorned with breathtaking rings and home to one of the most intriguing moons in the solar system, Titan. Perhaps the most astonishing revelation of this leg of the mission was related to Titan, Saturn's largest moon. As Voyager 1 flew past it, scientists were astounded to discover that Titan's solid core had a smaller diameter than Ganymede, despite Titan being shrouded in a thick atmosphere that made it appear larger from afar. This challenged previously held beliefs and prompted a re-evaluation of how moons formed and evolved. The probe also revealed that Titan's dense atmosphere was primarily composed of nitrogen with traces of methane and complex hydrocarbons. an atmospheric makeup strikingly similar to that of early Earth. Although Voyager 1 was unable to see Titan's surface due to the thick orange haze, it provided strong evidence that liquid lakes or seas could exist beneath the clouds, paving the way for future missions like Cassini, Huygens, which later confirmed the existence of methane lakes. Moreover, Voyager 1's approach offered unprecedented views of Saturn's rings. What once seemed like uniform bands through telescopes were now revealed to be composed of thousands of smaller ringlets, each a delicate structure of ice and rock particles, ranging from microscopic grains to large boulders. The rings displayed intricate wave patterns caused by the gravitational influence of Saturn's moons, adding yet another layer of complexity to the planet's environment. The spacecraft also identified several previously unknown moons orbiting Saturn and revealed intricate magnetic and radiation belts that hinted at dynamic processes happening deep within the gas giant's core. A legacy of discovery. The discoveries made by Voyager 1 at Jupiter and Saturn were more than just data points. They were revelations that forever altered our perception of the solar system. Each encounter unveiled phenomena that defied expectations, challenged theories, and inspired countless new questions. By capturing stunning visuals, analyzing complex atmospheric compositions, uncovering geologic activity, and mapping planetary magnetospheres, Voyager 1 expanded the frontier of human knowledge. Its journey stands not only as a testament to human ingenuity and curiosity, but as a gateway to understanding our place in the vast cosmos. And yet, the Voyager story doesn't end at Saturn. As the probe moved beyond the gravitational grip of our major planets, it ventured into a new and uncharted domain, interstellar space. Becoming the first human-made object to do so, the Voyager missions unveiled the magnificent moons of Saturn in unprecedented ways, providing invaluable data that continues to fuel scientific research decades later. These missions stand as a towering testament to human ingenuity and the unquenchable thirst for exploration and discovery. Voyager's meticulous exploration of Saturn marked a significant milestone, unearthing astonishing findings about our nearest gas giant neighbor. Despite Saturn being one of the most studied planets in our solar system, the mission revealed that even worlds we think we understand can still harbor unexpected surprises. These discoveries remind us that close, detailed examination often uncovers hidden complexities that reshape our understanding. While the Voyager probes gathered a wealth of information during their initial flybys, their journey did not end there. As they continued on their path toward interstellar space, the probes presented scientists with a unique opportunity to delve even deeper into the nature of these planets and their surroundings. Through detailed investigations, the Voyager spacecraft revealed new phenomena, expanding our knowledge far beyond what was previously imagined and setting the stage for future exploration of the outer solar system. With meticulous data collection and thorough analysis, the Voyager missions provided scientists with a deeper understanding of Saturn's atmosphere, magnetosphere, rings, and moons. The probes uncovered new and intricate features, such as complex ring structures, dynamic storm systems, and previously unknown atmospheric phenomena. These findings dramatically expanded our comprehension of this gas giant, revealing its secrets in ways that had once seemed unimaginable. The wealth of data gathered from Voyager's in-depth studies not only enriched our knowledge of Saturn, but also deepened our broader understanding of the outer solar system. These missions continually fuel human curiosity and the drive for exploration, standing as a powerful testament to human ingenuity and our relentless pursuit of cosmic knowledge. Voyager probes are forever remembered as pioneering endeavors that broadened humanity's horizons and unlocked new mysteries within the universe. In a groundbreaking announcement in February 2023, astronomers revealed an astonishing new discovery. They had identified 12 new moons orbiting Jupiter, bringing the total confirmed number of moons around the gas giant to an unprecedented 92. This remarkable finding highlights that even decades after the Voyager missions, the outer planets continue to surprise and captivate us, offering endless opportunities for discovery. This extraordinary discovery firmly establishes Jupiter as the planet with the highest number of natural satellites in our solar system, surpassing the previous record held by Saturn, which has 83 moons. The dozen newly identified moons were detected and carefully observed using advanced telescopes located in Chile and Hawaii during 2021 and 2022. Following meticulous data collection and rigorous analysis, the discovery was officially confirmed in 2023. This remarkable finding adds significant depth to our ever-growing understanding of the complex and dynamic Jovian system, offering new insights into the intricate gravitational ballet performed by the numerous moons orbiting this massive gas giant. It also highlights the continuous advancements in astronomical observations and reflects humanity's unrelenting curiosity to explore and unravel the mysteries of the cosmos. After their initial detection, the orbits of these new satellites were meticulously tracked and confirmed through extensive follow-up observations conducted by a dedicated team of scientists. This further in-depth analysis has not only validated their existence, but also helped refine our knowledge of their orbital characteristics, stability, and interactions within Jupiter's vast gravitational influence. The discovery of these moons serves as a reminder that despite centuries of astronomical study, our solar system continues to hold surprises, and each new revelation brings us closer to understanding the full complexity of the cosmic neighborhood we call home. Further investigations into these newly discovered moons revealed intriguing details about their characteristics. Ranging in size from 1 to 3 kilometers, these moons were identified as regular satellites exhibiting retrograde motion, meaning they orbit Jupiter in a backward direction, opposite to the planet's rotation. This unusual orbital behavior highlights the complex gravitational interactions shaping the Jovian system. Moreover, astronomers determined that the moons display a diverse range of orbital periods. Some take several years to complete a single orbit, while others complete their journeys in just a few months before repeating the cycle. This variation showcases the dynamic and intricate motions of these celestial bodies within Jupiter's vast gravitational sphere. These recent discoveries offer compelling new evidence supporting the pioneering observations made during the Voyager mission of 1979. That historic mission had hinted at the existence of a significant population of moons around Jupiter, and now, with the addition of these newly confirmed satellites, astronomers possess even more robust data to confirm Jupiter's remarkable abundance of natural moons. Such findings underscore the continuous progress in our understanding of the Jovian system and provide valuable insight into the complex dynamics governing the interactions among Jupiter's moons. They fuel our scientific curiosity and deepen our appreciation for the wonders of the universe, reminding us that despite decades of exploration, the cosmos still holds countless mysteries waiting to be uncovered. In the coming months and years, several ambitious space missions by leading space agencies are poised to deepen humanity's understanding of Jupiter and its intriguing moons, ushering in a new era of planetary exploration. Among these, the European Space Agency, ESA, has set its sights on launching a sophisticated spacecraft in April 2023. This mission is designed to study Jupiter and its diverse icy moons with enhanced precision and advanced instrumentation, aiming to unravel the mysteries that surround these distant celestial bodies. The spacecraft will focus on gathering comprehensive data about the planet's atmosphere, magnetosphere, and the unique geophysical features of its moons. Simultaneously, NASA is preparing to launch its highly anticipated Europa Clipper mission, slated for the near future. This mission targets Europa, one of Jupiter's most enigmatic moons, long suspected to conceal a vast, potentially life-supporting ocean beneath its thick icy crust. The Europa Clipper aimed to perform detailed reconnaissance of the moon's surface and subsurface, analyzing its ice shell, ocean depth and composition, as well as identifying possible locations where life could exist. By probing the ice shell's fractures and geysers, the mission seeks to better understand Europa's habitability and assess its potential to support microbial or even more complex life forms. These forthcoming missions promise to deliver an unprecedented wealth of data and insights, fundamentally enriching our comprehension of the Jovian system and advancing the broader quest to understand the conditions necessary for life beyond Earth. The discoveries made by these spacecraft will not only expand our knowledge of Jupiter and its moons, but will also shed light on planetary formation, geological processes, and the dynamics of icy worlds throughout the solar system. Breakthroughs in studying gas giants like Jupiter and Saturn have, in recent decades, opened up entirely new mysteries and avenues for exploration. These planets are not just distant giant worlds. They are dynamic environments with complex weather systems, powerful magnetic fields, and a rich collection of moons, many of which may be ocean worlds. Understanding these systems can provide key insights into the early history of the solar system and the potential for life in environments vastly different from Earth. Looking to the future, advances in space travel technology such as theoretical developments in light speed or near-light speed propulsion may one day allow astronauts to visit the surfaces of these gas giants or their moons directly. While such technology remains speculative and faces significant engineering and physical challenges, it embodies humanity's relentless drive to push boundaries and expand the frontiers of exploration. Visiting Jupiter's and Saturn's moons in person would revolutionize planetary science by enabling direct sampling, detailed surface studies, and on-the-spot investigations of their atmospheres and geophysical characteristics. As we continue this unfolding journey to uncover the secrets of our solar system and beyond, the role of these upcoming missions cannot be overstated. They represent humanity's insatiable curiosity and unwavering commitment to exploring the cosmos, reminding us that despite centuries of study, the universe remains a vast frontier filled with boundless wonders and unanswered questions. We encourage all space enthusiasts and curious minds to stay tuned for updates from these groundbreaking missions, follow the latest discoveries, and share their thoughts and excitement about the future of space exploration. Together, we partake in an unending voyage towards unlocking the secrets of the cosmos, a journey that promises to transform our understanding of the universe and our place within it. The wonders of space exploration truly are boundless, and each new mission brings us closer to grasping the full majesty and mystery of the heavens above.